Hey everyone, welcome back. So we have just done how to label our right angled triangles. So now we're going to move on to the trigonometric ratios, all right? And where do they actually come from? All right, so what I want you guys to do, I want you guys to copy this table down, all right? On a piece of paper, in your workbook, whatever you're working on, I want you to write out this table, all right? We're going to fill in this table. So once you have that, I also want you to copy down a triangle that looks like this, okay? So it's a big triangle and then with 3 vertical lines running through it, creating right angles at the base, all right? So in our table, you can see we've got 4 different triangles. So this relates to the 4 triangles we can see in our big triangle. So we have triangle 1 is A, B1, C1, so this little triangle here. Triangle 2 is A to B2, B2 to C2, and then A to C2. Triangle 3 is to the 3rd line, okay? And then triangle 4 is our whole large triangle. So we've got 4 triangles all inside of one big triangle, okay? All of these triangles are what we call similar triangles, okay? Because every angle is the same inside of these triangles, we say they're similar, but what they'll have, the lengths of the triangle will be a different ratio. So a ratio, remember, we can do as a division, so one side divided by another side. So that would be a ratio of those 2 sides. So what I want you guys to do is on your piece of paper with a ruler, measure the length of your hypotenuse of triangle 1, the opposite side of triangle 1, and the adjacent side of triangle 1, and put those in their respective boxes in the table. I want you to measure that for each triangle, so measure all 3 sides for each triangle. And then once you have that, you can jump onto your calculator and calculate the opposite side divided by the hypotenuse, the adjacent side divided by the hypotenuse, and the opposite side divided by the adjacent. So we're finding the 3 different ratios, okay? Pause now, complete that, and once you're done, start the video again and I'll show you my filled out table, okay? All right, welcome back. So I have gone ahead and filled out my table down here. So I was measuring on my iPad, so our measuring instrument probably wasn't the most accurate we could have used, but the idea will stay the same, okay? So I've measured in millimeters, okay, just to get some accuracy. So my hypotenuse for triangle 1 was 49 millimeters. The opposite side was 21 millimeters and the adjacent side was 45. So then I went on my calculator and I just put in my values into my calculator. So my opposite over hypotenuse, I inputted 21 divided by 49, and that got 0.43. So I did that for all of my triangles, okay? Hopefully you noticed that in each column, so opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, hopefully you notice that the answers are actually either exactly the same or very, very close, okay? So there might have been some rounding errors, something like that. So what we've got here, no matter how big the triangle is, the ratio that is created by the angle of 30 degrees will always be the same, okay? That is what we can take out of this little investigation. So the 3 ratios that you have just calculated, so opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, they actually have traditional names in trigonometry. So we call the ratio for opposite over hypotenuse, all right, let me zoom in a little bit. We call that the sine ratio. So that's for sine, and we're actually missing a little e on here, all right? So that's for sine. For adjacent over hypotenuse, we call that cos, which is short for cosine, all right? So cosine of an angle will give you the ratio adjacent over hypotenuse. And then for the ratio opposite over adjacent, we actually have tan, which is short for tangent, okay? So tangent of theta will give you the ratio opposite over adjacent, all right? So they're the three ratios that we will use in trigonometry, all right? That will help us find unknown sides, unknown angles, all right? So for any right angled triangle with one angle theta, we have sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. All right, and these can be solved on your calculator by inputting the ratio and the angle. All right, so for example, if you have if you're wanting to find the sine ratio of 30, so our opposite over hypotenuse ratio, you would push the sine button on your calculator and then in brackets put 30 next to it, and it will actually give you the answer of opposite over hypotenuse, okay? Hopefully that is really clear where those ratios come from. In the next video, we will actually practice starting to use these ratios to find unknown sides. All right, so we'll see you guys next time.